Resume recall. Perfect. So it's very interesting topic today, natural hydrogen. So I'll get back to it in a second, but let me just quickly introduce myself for those who are new and who don't know about QPQ. We're an investment advisory, and we help green energy project developers to secure funding. Mostly it's project finance. We help to secure debt. We bring strategic equity partners. We have pretty large network of developers and investors. So obviously we help investors to originate projects and help developers to secure project finance, sell their projects. We are developing and establishing our own fund and validating some sources for DevEx, which is pretty difficult to find in the market. And so hopefully soon we'll be able to offer several options for DevEx as well. But in general, we support solar, wind, hydropower, geothermal, waste to energy, energy storage, and hydrogen production projects to realize, to secure various types of funding. Amongst our investors, we have private equity, infrastructure, pensions, sovereign funds, a lot of strategic investors. We work with pretty much all large IPPs, independent power producers. We work with EPC plus F who can provide financing, development banks, export finance institutions, and huge funds as well. So I'll be posting some links in the chat. So chat is disabled not to distract you guys from very valuable content that Aaron and Allegra will be delivering today. But you can please make use of a Q&A section where you can post questions. I hope there will be, there are quite a lot of questions being shared with us prior to the webinar, but I'll be looking forward to receive more questions from the audience. In the chat, you won't be able to post anything, but please go to chat. I'll be sharing links, useful links where you can submit your projects to us for review. Also, you will be able to download Allegra's and Aaron's presentation, and there will be some other useful links that you might want to explore. I'll share them now, and also I will be sharing them in the end for those who join later. So that's introduction from my side. So and I will quickly then now introduce Allegra and Aaron, and also the subject, the topic for today's webinar is the future of clean hydrogen may be underground. So exploring the science, the risks, and the ROI. So you will learn a lot of valuable things about the natural hydrogen, what exactly is the natural hydrogen and why it matters now, the pathways to unlocking subsurface hydrogen, global exploration hotspots, and many other things. But I will let our speakers to share this today. So we have here Allegra Hosford Scheirer, a consultant, board member, and adjunct professor, is an interdisciplinary geoscientist specializing in natural hydrogen exploration, basin and petroleum system modeling, carbon capture, utilization, and storage. And I'll let the rest, Allegra, you probably will be better to introducing yourself. And Aaron Mattson is a founder of Maffic Consulting Group, the first consulting firm dedicated exclusively to natural, or how they call it also, white hydrogen. So I really appreciate your time, Aaron and Allegra. Thank you for making yourself available and preparing the content for our audience. Please, the stage is yours. I'll be on the background. I'll be managing the questions that come through. So in the end, we'll have 10-15 minutes for Q&A session. So please post your questions through Q&A button that you should see in your navigation tab. And I'll be posting some useful links and presentation in the chat section. Thank you.
Thank you, Vlad. I'm really glad that you gave that introduction about what QPQ is, because there's a lot of folks on this call that probably don't know about your investment firm. And I did a geothermal webinar with you last year, and so I'm really glad that you now have a wider exposure. Welcome to everyone on the call. I see a lot of natural hydrogen experts here, but also there may be folks on the call that aren't too familiar with natural hydrogen, although it does seem to be in the news a lot. So hopefully Aaron and I will have some new things to share with you today. We could probably talk for 30 minutes about every single slide in the slide deck, but we won't do that. We will go through it, and we really want to take your questions. So hoping to leave a fair bit of time at the end for your questions and really be in conversation with you. So just to expand a little bit on, oh, this happened earlier when we tested where my computer was slow to respond. There we go. Just finish introducing ourselves. I am a full-time consultant. I spend about 90% of my time working on natural hydrogen and the rest on CCUS, geothermal, and oil and gas. I just retired from 16 years leading a petroleum system and basin modeling consortium at Stanford. And before that, I was at the U.S. Geological Society survey. I also serve as an independent director of Pantheon Resources, which is an oil and gas company that explores on the North Slope of Alaska. Aaron?
Yeah, so I come out of the oil and gas industry, but back in 2020, I started looking at white hydrogen and have been waiting for it to gain some momentum. And in 2023, it looked like it started to. So my background has been more on the commercial side and strategy. And my focus in natural hydrogen specifically now is on understanding the industry trajectory, what's happening, the industry insights, and looking at it from the standpoint from that an investor would look at it, and from the standpoint from an exploration company of what is going to define success in this industry. How does the science and the commercial, how are they intertwined? And so a lot of what MAPIC has been doing has been on working with explorers and working with investors to kind of bridge that gap of understanding to help the industry move forward.
Fabulous. Good. And Aaron and I do work a lot together, although we have our independent firms. We just gain a lot of value by sharing each other's expertise and knowledge and learning about what each other does too. So that's been a really synergistic relationship. So thanks for doing this with me today, Aaron. So just setting the stage for those of you who are new to natural hydrogen. I know there's a lot of experts, but I do want to set the stage for what it actually is. Hydrogen is generated by geologic processes in the subsurface and trapped. This is a cross-section from what a typical oil and gas trap might look like, both stratigraphic traps and structural traps, where you may have water in the system, fault traps, but the same is true for natural hydrogen. We're looking for this light, mobile molecule in the subsurface in very similar traps as we would look for it in oil and gas. Natural hydrogen is also, though, probably going to be produced, and we'll talk about this, as something that we call stimulated hydrogen, where we will actually inject water into the subsurface and make chemical reactions happen. So how does this actually work? Hydrogen forms in many, many ways, and there's probably a list of 12 or 14 ways that natural hydrogen forms in the subsurface. But the three ones that you hear the most about are water-rock reactions in iron-rich rocks. So that's represented by that alteration little polygon there in the subsurface. These usually happen in basement-type rocks that are rich in iron, so ultramafic rocks. Also by the decay of radioactive elements that split the water molecule in the subsurface and liberate the hydrogen, which then migrates hopefully up to traps. And then this, which is shown by the blue little squiggle there. And then on the left of the diagram, shown by sort of migration up a fault, probably degassing from the deep earth. And that's really what they call primordial hydrogen, or hydrogen that formed while the earth was forming, now leaving the earth through fractures from the deep earth, and then hopefully up to traps that we can find. Hydrogen is found all over the world. It's actually found in different rock types all over the world. So ophiolites, which are ocean crusts that have been thrust up onto land, banded iron formation, greenstones, lots and lots of environments. And this nice plot from Vyacheslav Zaganek shows regions where hydrogen has been detected in primarily oil and gas wells and other locations. You should note that there's great big areas on here that don't have a symbol. This is a plot from 2020, and South America doesn't have any symbols shown on this map, but the absence of symbols doesn't mean the absence of hydrogen. It's there, it's just not been reported as of the creation time of this map. And then you can see, I want you to just point out here in the second column, look at the number of different types of host rocks that hydrogen has been found. Kimberlite pipes, ore bodies, rift zones, salt deposits, all these different environments. It's fascinating. But focus in on this green symbol right here in West Africa. There is exactly one place in the world where hydrogen is commercially produced. Natural hydrogen is on production. And that's in Mali, in West Africa. As Doug Wick said recently, probably the least favorable place you would want to have a producing hydrogen well in order to spur on development for the rest of the world. It's not an easy place for the rest of us to actually work in. And this is a schematic from Omar Maiga's work that shows that a well has penetrated basement and that you have hydrogen both solubilized in water, so dissolved in water, and then probably existing as free gas in sandstone and porous rocks. And then it's capped in that well by different sill layers. So those would form your trap. But this is problematic, right? Because this is the only place on Earth where a hydrogen well is currently on production. And it turns out that the world uses a lot of hydrogen. In fact, this year, the demand for global hydrogen is about 100 megatons a year. Most of that about a third of that in the Americas, half of that in Asia and Oceania, and a quarter of that, or a little bit less than that, in the Middle East and Europe. So that is growing by 2% a year. But in order to meet 2050 guidelines on carbon reduction, decarbonization, that is probably going to reach, let's say, a median of 400 megatons a year, maybe as high as 600, 700 megatons a year. There is a lot of global demand for hydrogen. And it's going up, it's increasing in demand because it's just so versatile of a molecule. We can use it in so many different ways as a fuel, for power, for heating, in industry. There are industries like steel and cement that are very heavily dependent on hydrogen. And I've put a green box around fertilizer because hydrogen is required to make ammonia, and industrial ammonia production it's the chemical that is produced, the largest produced chemical in the entire planet. And about 75 to 90% of that ammonia that's produced goes towards making fertilizer. So it's essential to have hydrogen to make ammonia in order to feed the planet's people. However, all of the hydrogen that is used today in these different chemical and industrial processes is manufactured. About 95% of it is manufactured in very carbon intensive manners. In fact, every ammonia molecule that's made generates one carbon dioxide molecule. And so that's sort of encapsulated by this schematic here. If you look on the left, it's called gray hydrogen. It has I try not to use the colors at all costs. I almost never use the colors, but gray hydrogen, that's how 95% of the world's hydrogen is obtained today by taking methane gas or coal, doing steam methane reforming, and then emitting and letting CO2 off vent to the atmosphere. It's very low cost, but very high in emissions. Some hydrogen is produced in the world by so-called blue hydrogen, where you do that same method as for the gray hydrogen, but you sequester the CO2 underground. That's a little bit better and a little bit higher cost than what we currently do. Yet better in terms of the carbon intensity is so-called green hydrogen, where you take the water molecule, you split it in an electrolyzer using renewable sources, whether that be solar or wind. You can even do it with nuclear. That's near zero CO2 emissions, but the cost is even higher. And then on the right, the so-called white hydrogen, and I just want to do a shout out that gold hydrogen is not the same thing as white hydrogen. White hydrogen, which I call natural hydrogen, hydrogen that is generated in the earth by these water rock reactions, either the serpentinization reaction or the radialis reaction, or we can induce it by injecting water into the subsurface. This also has near zero CO2 load and hoping that this is low to very low cost. The DOE has a goal of about $1 per kilogram of hydrogen produced. I'm personally skeptical that we're going to get to that price, but we can talk to that later. So what Erin and I really want to do today is reflecting our two backgrounds. We really want to do a handshake here between the commercial aspect, the strategic positioning aspect of the natural hydrogen industry with the technical aspect. And together we join forces on this every day for our clients who tend to be investors, such as venture capitalists needing to do due diligence. And we also advise big companies and small companies who are looking to enter the natural hydrogen space on how best to do that. So in the next section of the talk, I'm going to let Erin talk about who's investing, and what the exploration looks like worldwide today. And then we will come back together and talk about what's been happening in 2025, what we think is going to happen in the next years, and then really want to be in conversation about barriers and breakthroughs. So, Erin?
Okay. So just to kind of give you an idea of where the industry sits by the numbers, and I will say this changes weekly. So I've probably added a few more companies since we even put this original slide together in the last couple of weeks. So currently there's 86 plus companies worldwide involved in exploration for natural hydrogen. That is a lot. They are going with multiple origin theories. So when Allegra talked about serpentinization or iron water rock interactions, radiolysis or deep mantle degassing, you've got companies that have hybrid models. You've got companies focusing on serpentinization, and the iron water rock is kind of the major focus for exploration in the United States currently, but you'll go other places and there are other models being put together. There's multiple drilling philosophies. Some companies believe that this hydrogen is going to be likely only commercial at very deep depths. So you're going to be drilling, 10,000 feet possibly into basement rock. There's basement play concepts. There's the idea that it can be found shallow, similar to moly, and that a better, more lower cost commercial model is to extract it in a shallower reservoir. There's models out there that the flow is significant and that concentrations of where that's going to go in a regenerative reservoirs is a model that can be used. So there's a lot of different philosophies on how to go about commercializing it. I would say at this point, it's a little too early to say which one is correct. We haven't drilled enough wells and we don't have enough data, but there is a lot of activity going on this year that is starting to show where that might, which model might prove out. So there's 12 different survey technologies. Every different company has their own workflow, similar to oil and gas. But I would say with natural hydrogen, there's a lot more diversity to what people are utilizing. Everything from your classics like seismic survey to a rethink and newer versions of old technology like magnetotellurics. Everyone's pretty much using aeromag data. So your mag grav data as well is getting factored into it. There's a lot of different technologies, and there's some very novel new technologies that are also quietly being used, or variations on existing technologies that are being used. So this is something I really am passionate about. There's 10 different geochemical interactions that can consume hydrogen. Hydrogen is a molecule. You can think of it as the party animal of the subsurface. It is interacting with everything. It dissolves in water. It interacts. It's one of the building blocks of a lot of other gases that we are more familiar with in the subsurface, such as CH4 methane, H2S. It has many mineral interactions as well. So as it moves, there are a lot of models on how do you account for that hydrogen interacting on its way to the trap. How much is actually going to make it there? There's 3 hypothesized migration methods. There's a lot of different.
There's probably even
if
more,
not
right?
more, yes.
Yeah, lots
Allegra
more.
can talk. Allegra could go way into depth on that. But you have this complexity within natural hydrogen, which is creating a lot of different workflows, concepts, and theories that explorers are working from. It's not a one-size-fits-all, this is the standard model of how everyone's doing exploration. Currently, there's probably close to $1 billion in investment to date. Now, some of that is tied up in milestones, so I wouldn't say all of that capital has been deployed. Companies like Coloma, which have hundreds of billions of dollars, likely tied to milestones. So the assumption that there's more than enough investment for the current level of exploration, I think, is not completely accurate. Given the fact we have 86 companies, it is a challenge given how much that is spread out across global exploration projects.
Yep.
So next slide. So who is getting involved in natural hydrogen? Mostly startups. That's kind of what we've seen. You're not going to see any major oil and gas companies running their own exploration side projects, although I will say there are a number of NOCs that have had groups researching it. But most of the companies have started up in the last couple of years. The most well-funded and probably most well-known is Coloma, which is based in Denver, Colorado. And they've been exploring in the Mid-Continental Rift in Kansas and Iowa. But most of the companies are relatively new and funding anywhere from $500,000 to $5 million, and some like Hytera in the 20 million plus. You've also got junior mining companies, so public companies that were involved in mining, mostly out of Canada, but also some out of Australia as well, that have jumped into natural hydrogen exploration. And when we talk about the iron-rich rock and the serpentinization reactions, a lot of the areas in Canada that are lucrative for mining also hold natural hydrogen potential, which is why you've seen some pivots by a large number of junior mining companies into natural hydrogen. You've got two major mining companies involved. Fortescue is backing Hytera, and then over in Europe you have Rio Tinto backing Snowfox Discovery. You've got industrial users like Mitsubishi Heavy Industries, as well as a number of other more quiet partners that have provided funding to a number of companies and taken an interest to position themselves in case it does become a large-scale industry. You've got a number of academic institutions involved. Colorado School of Mines is one that comes to mind largely because of their funding that they have for doing extensive research on natural hydrogen. And you should check out their LinkedIn content because there's a lot of interesting slides that they've put out on some of the research that they've been doing. Other ones have included Oxford, and there's work been done at Stanford, there's work being done at UC Berkeley, University of Texas, Austin. I'm sure the IFP's done some stuff, and I'm sorry if I leave it out, but there is a lot of other international research at academic institutions in Australia, across Europe. So it is getting a lot of academic support, which this needs. Government agencies, I could go on for a lot of this, but the one I'll probably give a shout out to is ARPA-E. So Department of Energy's ARPA-E has provided a lot of grants to stimulated hydrogen research across the US, and there's a number of projects that have gotten their start from that. Oil and gas companies, mostly not with an asterisk, because while they might not be, you have companies like BP Ventures, which has took an equity stake in Snowfox Discovery. You have Total, which invested in 458 for its helium exploration, but it's going to benefit from its natural hydrogen exploration. So you're not seeing the Chevrons, the Exxons, and when I say publicly, the large NOCs. In the background, there are people at those companies that have researched this. There has been research done on this, but it's so new, it's so emergent, and it just does not fit the standard risk portfolio for an oil and gas company. So we're kind of on a wait and see with major energy companies jumping into this at this point.
Yep. Aaron, let's speed up a little bit just so we don't run out of time.
So these are the major investors, which I've kind of mentioned. Most of them are VCs, but you got Rio Tinto, BP, Amazon Climate Pledge, some surprises like United Airlines in there. So a lot of variation in who's investing right now. Next slide. You have two different ventures set up, Natural Hydrogen Ventures and Natural HY. So those two have set themselves up to allow investors to have broad exposure to various private startups. and they invest in a number of different companies. So if you don't want to pick one, they are trying to make the best picks and create a portfolio of investments more broadly across the industry. And Renaissance Philanthropy, I got to throw that one in there too.
Yeah,
they're rather new.
All right, so let's turn towards where are people exploring? What are their guiding philosophies on what they're going for, and who they are, where they're doing, and then we're going to use in the next series of maps. Erin's going to talk about the next series of maps. We're going to use this color map to or heat map to really indicate what the maturity level of exploration is. So if it's green, they're in the beginning stages, they've done some due diligence and done desktop work. If it's yellow, they've actually gone into the field and done some sort of gas surveying, maybe some even leasing. If it's orange, it's all of the previous activities plus more leasing, maybe some grab and mag, maybe some seismic surveying. And if it's red, they've done all of that and also drilled wells. So I think we can move through the next series of maps pretty quickly.
So here is the global state of play.
Yeah, love it. Love it.
I'm just going to highlight the major ones by continent. So you have Australia with gold, hydrogen, H2EX, and a number of Australian explorers. Gold hydrogen has drilled wells there, so you do have that marked red. Mali is marked red for the first well that was drilled there. And then you have the United States, which obviously there's a lot of exploration going in Kansas, Iowa, along the Mid-Continental Rift in the Midwest of the United States. There is active wells currently being drilled right now in Kansas. So a lot of the drilling and exploration has occurred within the United States. Canada is catching up pretty quickly, though. Yeah. You've got Max Power out in Saskatchewan with plans to drill wells. You have a new announcement, actually, as of this last week. More announcements to come this week from Record Resources saying they have a drill-ready prospect they're moving forward with in the next quarter down in Alberta. You have QIMC over in Quebec with its 5,000-meter drill plan. They're drilling shallower wells across multiple areas over there in Quebec. The entire Canadian Shield makes Canada very, very lucrative for natural hydrogen exploration. Challenges there, though, are going to be sedimentary depths and the quality of the reservoir and seal. The U.S. is going to be a little bit more diverse, and you're going to find exploration along the fringes of existing oil and gas basins to start out, although I expect that'll change. So let's go to the next one. Yeah.
We can go through these pretty quickly so we have time to really go through the breakthroughs and barriers and stuff.
So as I mentioned before, Mid-Continental Rift, you got Iowa, Nebraska, Kansas, Arizona, all those places have had wells drilled. All the ones in green currently have some level of survey ongoing, either for stimulated or natural. And you have various levels of survey in the other parts of the Southwest. There is more to this, but if I can't find enough sources to confirm something, it doesn't show up in this map. So.
And I'm glad you said that, Erin, because everything we're showing today are things that are available publicly. Even though Erin does incredible work finding information out from courthouses and from scrubbing meeting notes of community meetings, it's all public information.
So Canada, as I said, is heating up. You've got Saskatchewan, Ontario, and Quebec with active exploration that's moving through various phases of geophysics. And in some cases, plans to drill wells.
And I expect we'll see a well drilled this year, right, Erin? Do you agree?
Where?
In Canada. I expect we'll see a well drilled in Canada this year. Do you agree?
I think there'll be multiple wells drilled in Canada this year. There's also some quiet exploration going on in Ontario that I expect to see probably 1 or 2 wells spudded for there. And it's basically expansion started, or the growth started in Ontario, Quebec, moved to Saskatchewan, and is moving west in Canada. So that's kind of what you see there. Australia has had a lot of attention. There's a lot of potential there with their basement rock to be ideal for a lot of different generations of hydrogen. The major projects are Gold Hydrogen's Ramsey 2, which was drilled in 2023. There's extensive work that's been done by, and I'm going to pronounce this wrong, but Cicero. But there's a number of companies that have been in it for a while, like H2EX down there, but most of the concentration activity is down in South Australia, largely due to the regulatory environment there currently. And then you have Europe. So Europe is kind of leading the way in research. A lot of research and publications are coming out of Europe. Has strong research academic support, but the regulatory environment for drilling there is going to take some time to catch up with the US, Canada, and Australia. So there is exploration ongoing there. And largely in France is getting most of the attention by companies like 458. And let's see, I'm trying to remember the other ones, but there's like 6 or 7 in there. But I would say 458 is probably in the most advanced stages of their exploration.
And hopefully they get a well drilled this year.
Yep.
So
I think there's.
Yeah, sorry.
I'll hand it over to you.
So when we think about stimulated hydrogen is a really promising technology, and we could talk for a whole hour about that. But there are a lot of questions that are remaining about stimulated hydrogen. And right now, all of the focus on stimulated hydrogen is taking place in the lab. Folks are doing experiments in pressure vessels, on powdered rock samples, and twisting all sorts of knobs, such as catalysts that are being used to speed up the reaction, to make the solution more alkaline, controlling salinity. They're looking at different iron contents. Some of the rocks are already serpentinized. And so that's why I have in the lower left those sort of pillars that are meant to represent the fact that at the moment, all of these labs, mostly academic labs, are operating pretty independently and are a bit siloed. And there's just a lot of different parameters and knobs that they're all tweaking. At some point, that's going to all need to come together. And I do expect in 2025 that we'll see a simple 2-well setup, just shown by this diagram, where you have an injection well of water and a monitoring well, and we'll actually get a test down into the subsurface this year. Offtake is still largely theoretical, though. What are we going to do with this hydrogen once we produce it? Initially, it'll be largely local, right? So Hytera is drilling in the MCR right now, the Mid-Continental Rift. They are really lucky to be surrounded by the need for petrochemicals and ammonia in that state, and also ethanol. Eventually, we hope to have large-scale transport of hydrogen, possibly as liquid ammonia, and maybe in pipelines, although there's only about 6,000 miles of hydrogen pipe in the US at the moment. And so the offtake is yet to be developed because hydrogen production at scale is yet to be developed. 2025 has been busy. All of you know who are in natural hydrogen, the landmark study that came out in January that the USGS mapped the prospectivity for geologic hydrogen for the lower 48. Their Alaska prospectivity map is coming out next month, I believe, and they are working on a version 2 of that prospectivity map. And I know that Canada is also working on a similar type of publication. I think that we've already seen leasing this year outside of the Mid-Continental Rift, and there's been partnerships, as Aaron said, between Colorado School of Mines and First Atlantic Nickel in order to look at ophiolites in Newfoundland. Hytera is really going to be a game changer this year. They've spudded their second well in the last couple of months, last week, I think, or 2 weeks ago. Looking at hydrogen and helium there, they've also released the percentages that was obtained in the 40 well. Many of you know that's the Nebraska well that was the first one drilled in the United States for natural hydrogen. They've done all sorts of geophysical campaigns, and they've got permits to drill 6 wells this year. So it's already been busy. Aaron and I really think that the outlook for 2025 is going to include regulatory acceleration. Right now, regs are really done on a state-by-state basis. We think investment's going to increase, but we have an asterisk on that. We'll bring that up when we get to the challenges section. There will be a stimulated hydrogen field test that's already been announced, and the prospectivity mapping that I mentioned. And then also widespread use of techno-economic analyses. I just have a little graphic there from a student in my research group from Stanford, but there's many different TEAs out there, including one by Alexis Templeton that's online. You can twist the knobs yourself from economic things like CapEx and OpEx to geologic parameters such as well spacing and iron content. That's a really fun TEA to play with, and Aaron has developed his own TEA also. Here's what we think is coming on the technology side beyond this year. I'm very excited about clumped isotopes. That's an extremely niche, specialized field. Nevertheless, that could tell us something about the formation temperature of hydrogen. Reactive transport modeling, we know almost nothing about that in terms of natural hydrogen. Muon tomography, I'm just throwing it out there so that you can say, I heard Allegra say it first. That's a very, very cool technology involving cosmic rays. Of course, AI, we don't even need to mention. And then gas separation is going to be key, right? Because when you produce natural hydrogen from the ground, you're probably going to co-produce gases such as methane, nitrogen, CO2, and you're going to need to separate those out so that you can then send the hydrogen off to be used. As a geoscientist, what I look at other technological advancements, especially someone who comes from the oil and gas side of things, I think that oil and gas workflows will be more heavily incorporated into natural hydrogen. The natural hydrogen community is really composed now of folks from oil and gas side and folks from the minerals or mining side. And so I do think that we'll have FWI for seismic processing, some play chance mapping, discrete fraction networks on the stimulated side, because we'll need to inject water, break open the rock, and let the hydrogen flow, and then basin modeling. I do want to mention the fact that helium is often co-located with hydrogen. It's produced in very similar geologic ways, similar migration behavior, similar solubilities in water, i.e. not very soluble, similar trapping. And Erin, would you just say something before we get to challenges about the economic benefits of producing hydrogen when you find producing helium when you find natural hydrogen? Oh, Erin, you're on mute.
In some cases, with the percents being recorded for not necessarily flow, but concentrations of 2 to 5%, should they find a helium with hydrogen, anything above 0.3 is likely going to be commercial for the helium alone. So when you're talking to 3% helium with, the hydrogen content, the economics is significant for having helium co-located with hydrogen. So as production costs might be a little high for hydrogen as we start out, the helium really significantly de-risks the projects as they move forward. So I foresee helium being a major focus for hydrogen companies for co-located gases and how they're commercially thinking about exploration.
And really funding their hydrogen exploration on the back of selling
Funding
that
it too. Yeah.
Absolutely. So what Erin and I want to do with the last two slides is really introduce both challenges and breakthroughs that we are thinking about every day in our work as we help our clients make this a success. And then I see several questions in the chat. So we will go first to challenges, which I called barriers, and then I changed it this morning to challenges, being more optimistic there. So there's always geological complexity and detection challenges, right? That's sort of the big picture of this is really brand new days looking for geologic hydrogen. Yes, it's been thought about for, maybe 15 years. Agonic was sort of what the leader in that when there was only a handful of people thinking about it. Also, Vladimir Lerin in Soviet Union, but it's really early days. And so we're just starting to develop the geologic models for how does hydrogen, et cetera. Hydrogen leakage. Hydrogen is a teeny tiny molecule. It's going to leak. We already know it leaks to the subsurface because we can detect hydrogen in soils. So that will be something that we need to make sure that we contain it when we do. And I just want to bring up production rates because there is a question from Anthony on the chat about production rates. We don't know anything about production rates in the field, Anthony. So all of the production rate information that we have of hydrogen per volume of rock are based on lab experiments on powdered samples, not on intact cores. And so that is going to make because we don't know anything about that really, it's make the economics of this really difficult. And Erin, you want to talk about the economic challenges that we're facing?
Yeah, so I mean, it really does come down to production rates and flow and pressures and everything of that nature. We just don't know what we don't know at this point until we have a well that is flowing and producing, understanding the full economics. I mean, we've modeled it out. I can tell you that I wouldn't produce a well that didn't have that was under 250 MCF for hydrogen at purity. So when you consider the other gases that are coming out, the purity is going to have a huge impact too on the economics for gas separation costs. The helium content too, at 250 MCF, you need to have a helium component. So when we talk about these numbers and ranges, it's really hard to give anyone a clear number of what that looks like, because it's going to vary based on gas composition.
And I think also, Aaron, there will be a lot of dry wells that are drilled. And one thing that really concerns me regarding investment is that investment for natural hydrogen is coming from venture capitalists, larger firms. We don't know what their appetite is going to be for dry wells. So it used to be said that if in oil and gas, when you're opening up a new unconventional play, it took 30 wells to open up a new shale play. Well, my question is, do the funders have an appetite for 30 dry wells for natural hydrogen? Or will a couple of failures here and there lead to the collapse of this industry? We really hope not. We really hope that people hang in there. But I think one thing that Aaron and I both feel strongly about, and this may be a little controversial, is that there are too many small hydrogen companies out there right now, and that the amount of investment probably cannot sustain that many startups in natural hydrogen. We think there'll probably be some consolidation, but we're also very excited about the number of people who are excited in natural hydrogen. That said, an additional issue that comes with having so many startups that are working is that there's a lot of secrecy, there's a lot of IP. And so that really is a barrier to information flow. And everybody developing their own secret sauce, as it were, for example, for stimulated hydrogen, means that the things they learn aren't going to be shared with the next stimulated hydrogen company down the street. And that just makes everything take a lot longer. So
in a perfect world, let's say evolutionary, as the funding dries up to certain sectors of this or certain companies, there would be an investor who comes in and realizes the various IP and talent within these teams and consolidates it into one and properly funds it for exploration. We need, at least 10 to 15 companies globally working in this industry. We have 86 right now. There's not enough funding to sustain these companies, and you're gonna, you can make comparisons to evolutionary biology for where this is likely going to go. That could change if there's a massive increase in interest in exploration. But there's a lot of science, a lot of research, a lot of intelligence and learning that needs to happen for this industry to really pick up.
And so to that point, some of the things that need to happen are improvement to how we detect hydrogen at the surface. Many of you know that we do that now with soil gas sampling in situ, but then also hyperspectral type of analysis. Again, we don't know how well these are going to predict a flowing commercial size well, right? These are all just giving us the background information that we need to then go into these areas and drill. We'll continue to work on migration models of hydrogen because we just need to know get a better handle on how it moves from source to trap and characterize the reservoir better. I do want to put a plug in for looking at other types of rocks. We've been so hyper-focused on olivine and peridotite. And as I mentioned earlier in the talk, hydrogen is produced in so many different types of geologic environments that we can actually expand our lens and look a little further afield. Myself and others are a real big proponent for a national test site that probably needs to be developed by a public-private partnership. That's something that Renaissance Philanthropy is very interested in. And so I think that would go a long way towards improving, just actually pushing out knowledge to this huge landscape of companies that are out there. And then I put I should have put offshore question mark. That's just to be provocative. Like, should we think about exploring for natural hydrogen in the offshore? That's something that might be on folks' radar screens, but isn't really talked about yet. So Vlad, I see that if it's okay with you, I see that there are a number of chats.
Yeah.
Sorry.
Shall I read it out to you and you guys
Sure.
answer? Yeah. So, well,
Sure.
first question just from me. You mentioned in the beginning that gold hydrogen is not the same as white hydrogen. Perhaps you explained it, but I missed it. What is the difference?
Yeah, so technically gold hydrogen is produced by microbes in oil and gas wells. But the phrase gold hydrogen is so often conflated with white hydrogen. And so I just wanted to say that out loud. I never use colors of hydrogen, so I always say natural or geologic hydrogen.
Interesting. And do you think that considering the low efficiency of green hydrogen, well, like electrolyzers
Yeah.
and producing
That's
green
right.
hydrogen, do you think that natural hydrogen has, all the chances to become, to surpass the green hydrogen?
Oh, I do. I mean, green hydrogen was such a big deal in the early 2020s and has sort of collapsed. I'm hoping that it comes back, but because there's a dependence there on critical minerals, it becomes a little bit more problematic in terms of scale up and cost.
And also, I think electrolyzers, that's, I think the efficiency is somewhere around 20%, if I'm not mistaken.
Yeah.
Yeah, so
Yeah.
perhaps until some more, technologies with high efficiency will come up, that won't be feasible, I suppose.
Agreed.
Yeah. Okay, well, so one of the questions is key drivers to define scale for hydrogen projects and usual ROI for such projects.
Key drivers to
Define scale for hydrogen project.
Aaron, do you want to take that?
Yeah, it's a little bit challenging to answer that with how that was. So I'll start with, I mean, as far as scale goes, it's going to come down to what the size of the reservoir in the subsurface.
Yeah.
Also, the scale is going to depend on offtake. So we don't have hydrogen pipelines in just about anywhere exploration's ongoing. So then you're going to have to look at what your offtake options are. If it's an AI data center that you're feeding with electricity, that's a different thing, but there's a scale that has to be supported for that. So, I mean, everything is going to be a constraint of how much subsurface hydrogen that there is. And I don't think at this point we have enough research to say that there's a reservoir out there that can sustain 500 wells or 100 wells or 20 wells. Whether this is going to be, pockets where we have one well here, one well there, and we're indiscriminately placing them based off of where we're identifying accumulation of the subsurface. So what is the potential scale? I think that is a valid question for commerciality of the industry, but I don't think we have enough information to really say that at this point.
We don't, and we also we don't know to what extent these reservoirs are naturally replenishing. There's some idea that perhaps that's occurring in Mali, but we just don't know how that's going to build out over time.
Very good. So I suppose the second part of this question, that the ROIs really depends on, on the scale, on the, the exploration cost, and then, that really, but to make it attractive for investors, I suppose it has to be in at least double digit, 10+% or something like that.
Yeah, I don't know yet.
Yeah.
I mean, yeah, it's hard to say. We've modeled it out. We have a techno-economic lifting cost model that we look at variations. And like I said before, it's going to depend on your gas content. Costs that have been modeled out are anywhere from 50 cents to $1.50 to naturally extract it. So you're still well within a strong cost basis with all other forms of hydrogen that are out there, both steam methane reforming as well as green hydrogen. So from a cost basis, it's probably the most competitive form of hydrogen out there. The question is scale. So we have
logistics,
and that's
I suppose
going to
logistics as well. You touched upon transportation. In the beginning it will be all used locally, but then they have to transport it. Then
that's right.
Local offtake is going to dominate in the early days.
Yeah. Okay.
Question from Samir. He was surprised that Manitoba is not exploring this. So Manitoba, you're familiar with?
Manitoba. Yeah, I mean, they definitely have the correct greenstone belts and sedimentary basins that could serve as traps. Aaron, have you come across anyone exploring in Manitoba? I think it's in
There's
the
no
early,
one public. There is no one
yeah, no
publicly
one
exploring.
publicly. Yeah.
Mhm. All right. And what is the relevance of AI to natural hydrogen in this specific case, aside from perhaps geological search?
Yeah. So I'll start. Aaron could take a little bit. So Aaron and I have developed an AI tool that we use for research in natural hydrogen. It's a highly trained AI agent. But I also think that AI workflows that are already in use in the mineral industry and in or mining industry and in oil and gas are going to be brought in, say, to interpret seismic data more intelligently, to interpret mag-grav data, for example. So it's all going to be incorporated into the different workflows that we do. Aaron?
Yep, I'll throw in there too. So I think the biggest potential for AI is something that's a little passion project of mine is has to do with integration of data sets. So machine learning potential, given that there's so much that we don't know about natural hydrogen, the ability to take 6 different survey data sets and to use machine learning to find out what we don't possibly know
Yeah,
between the number of survey technologies that are out there. The aeromag data, the modeling that's done off that is going to possibly have, there's learnings that we're going to come from integrating that with some of the seismic. There's going to come from
absolutely.
integrating that with things like magnetotellurics and other sorts. I'm going to say that there's a lot of testing out there for other forms of survey technology right now. And given the volume where oil and gas is hyper focused mostly on seismic, the number of tools that we need to properly survey and understand the subsurface for natural hydrogen is high. So it's a perfect opportunity for integrating ML models and then maybe even capping that off with generative intelligence.
Very good. Thank you. And at which stage of development could there be an appetite potential investors for H2 well?
What stage of development? I mean, so investors are getting involved pretty much at all stages, Vlad and Ron, from funding the basic science that goes into understanding how hydrogen systems work, to funding the surveys that are needed to be done for due diligence at a potential site, and into drilling a well. But at this point, all investors need to know that the money that they put in initially is going to be quite a bit of used for the research that needs to understand how hydrogen systems work. As Aaron said, it's tied to milestones, but it's really being deployed across the entire life cycle of a natural hydrogen system development.
When you're investing in a well, you're not just investing in the commercial extraction. This is very different because you're also investing in what's learned. We cannot expand this industry. Research will not get to the point where we can commercialize this if we do not drill wells. A lot of the surveys where we learn the most is when we drill a well. So when you drill wells and you integrate that into your exploration model is your IP, and that IP is going to inform your capability to scale up and commercialize this. So when we talk about drilling and investing in drilling, part of your investment is investing in R&D that comes from drilling the well, not just the resource extraction. And I just wanted to point that out, that it's a little bit different because we don't have a series of commercial wells online right now. So you have to consider that a component of your investment is going into R&D and IP.
That's a great comment, Aaron, because from my understanding, on the example of geothermal, what we're seeing, a lot of investors don't want to go for the exploration. And I suppose this because it's already not as much, IP there because it's well known, but it's more of a risk, and whether you will get the resource, hit the right, geothermal resource or not. With natural hydrogen, I suppose it's different because there is still a lot to learn, and then protect that IP and use it in case it becomes
That's right.
large industry. Yeah.
That's right.
The perfect example.
So with the millions of wells drilled around the world for oil and gas, mining, water, etc., any work being done to scan those well logs to find hydrogen indicators in those logs that may have been bypassed hydrogen pay?
Yeah, many of us, especially those of us who've worked in oil and gas for decades, are scanning and web scraping as many public data sets as we can, because oftentimes hydrogen was recorded in these wells. Not all the time. Sometimes the gas chromatographs on an oil and gas well use hydrogen as a carrier gas to do the measurements of the gases. So you can't actually detect hydrogen when you're using hydrogen, but there are thousands and thousands, probably millions of hydrogen measurements in old oil and gas wells. And Eric, that would be a perfect application for AI and ML to go through and do a massive search and analysis on old wells.
Of the existing logs, yes. Okay.
Yeah.
And what are your thoughts on separating helium from hydrogen after purification of the other gases?
What are my thoughts? Well, yes, we should do it, Rob. Aaron, do you want to talk about separation?
Yeah, so I mean, a lot of it's going to depend on what your intended purities are, but yes, everyone is looking. I mean, I think one of the companies that's been talked about pretty extensively within natural hydrogen has been a company called H2 Sites. So a lot of the membrane separation technology that applies to green hydrogen and other hydrogen manufacturing is being looked at for this for separation. So yes, we will have to separate. There's 3 different separation processes that could be used, such as like PSA and cryogenics. So I mean, it's going to depend on the purity that's desired for the helium. So
Very good. You mentioned that basically it improves the ROI of the hydrogen well if there is helium, right? So basically, helium is being extracted and then also as an extra revenue stream, right?
That's exactly right. You don't need a high percentage of helium, Vlad, to make money on it. In fact, much of the country, the Four Corners, sort of Rocky Mountain area has helium in very high, greater than 3%, but the rest of the country is basically less than 3% and still is economic helium accumulation. So you don't need a lot.
Perfect.
strategically optimizing places with radiolysis and serpentinization is probably something you'll see explorers do.
Very
Because
good.
radiolysis is also going to be part of the helium creation.
All right, great. Well, I really appreciate your time and very interesting content. It's the first time we're talking about natural hydrogen. There was several sessions, webinars in the past talking about hydrogen or green hydrogen, but that's definitely something new. I really appreciate you spending time and delivering it in such a easy and easy to understand way. Thank you for everyone who attended, and I have shared in the chat the presentation that Allegra and Aaron prepared. Also some
that's an old one. Sorry.
That's an old one?
Yeah.
Oh, that's okay. No problem. We will be sending to everyone who attended and who missed today's webinar. We will be sending them an email tomorrow. With a link for the webinar replay, and we will attach the most up-to-date presentation. Please share it with Amira so she will take care of this. And there are some useful links where you can submit projects if you have access to projects that require funding. Because as I mentioned at the beginning of the call, at QPQ we support developers with securing project finance and selling their projects within not only hydrogen but green energy space. If you're not developer but you have access, or within your network someone is looking for funding, there is a referral partner program, and there are a few other useful links that you might want to explore. As I said, for those, because there was one last question, but it's actually not a question. It's basically someone's asking about recording. So as I said, we will be sending the presentation and recording to everyone, I think, tomorrow. So thanks again, Allegra, Aaron, great to see you again. And thank you for your time. Have a great rest of the day.
Thank you so much.
Cheers.
Take care. Thanks, everyone.
Thank you.
Thank you.